Alright, so chapter 5, vectors. So today we are going to focusing on 5.4, application of vectors in geometry. So this is the first part, equation of a straight line. Okay, so equation of a straight line, imagine this is the line. So equation of straight line, we can represent them by r equal to a plus dv. So a is actually a fixed point on the line. So if this is a line and you know one of the point, then you can replace them with a. So that is the fixed point. Meanwhile, v is actually a vector such that it should be parallel to our line. So we should find a vector such that it should be parallel to our line. So that is v. Okay, so if let's say I call the vector a or the fixed point as x1, y1 and z1. And then let's say I call the parallel vector as a, b and c. Then that means the equation of a straight line r equal to a plus dv. Then the equation of straight line is simply equal to x1, y1 and z1 plus with d multiply with the v, so a, b and c. Okay, so t is actually a parameter, so that means if you don't want to use t, you can actually use any other letter for it. So you can use s, or you can replace them with mu, or whatever letter that you want, because that is simply a parameter, so it doesn't really matter. Okay, so let us obtain the vector equation. We're gonna write them down in the vector form. So this is xi plus yj plus zk. So this is actually what is r. R is xi plus yj plus zk. So this is actually equal to a. So a is x1i plus y1j plus z1k. So this is your fixed point plus with d. And then the v is ai plus bj plus with ck. Okay, so this is how we write them down in the vector equation. So now if we want to have the parametric equation, we need to make sure we compare the I, the j and the k on the left hand side and right hand side. So if you compare the left hand side, for the I we have x, for the right hand side we have x1. And then over here we actually have a parameter t times with a, so this is x1 plus at. If you compare for the j on the left hand side, we're going to have y equal to, so on the right hand side I have y1 plus, and then I have b times with t, so plus bt, and then another one is z equal to, so this one is z1, and of course you're going to have ct. So the reason why we call this one as a parametric equation is that, as you can see over here, we actually write down x, y and z in terms of t. So we are using one parameter for the x, y and t. So that is the reason why we call this one as the parametric equation. So now, how do we obtain the Cartesian equation or the symmetry equation? So you're going to let the t as the subject from here, and then we're going to use equal for them. Okay, so for the first one, you're going to have x minus x1 over a. So you're going to bring x1 to the left hand side, divide them by a, equal to, so this one bring y1 to the left hand side, divide them by b, so y minus y1 over b, equal to, this one bring the z1 to the left hand side, so z minus z1 over c. So that is a Cartesian equation. So let us proceed to some of the example. Okay, so find the equation of a straight line that passes through the point. So we know that it must pass through one point. So I'm gonna consider this as the fixed point. And parallel to the vector, negative I plus 5j plus 3k. So I'm gonna let this one as the v because this is a vector that is parallel to the line. So the equation is r equal to a plus dv. This is the equation of the line. So normally the question will say whether do they want the vector equation, Cartesian equation or the parametric equation. But for this example, I'm going to do all three of them so that we can compare each equation. Okay, so let us do the first one, which is the vector equation. So for the vector equation, we're going to have xi plus yj plus zk. So this is r equal to a. So a is over here. So we're going to have 2i minus 3j plus with 4k. And then plus with t. So the v is negative I plus 5j plus with 3k. So this is our vector equation. Okay, so the second equation is called the parametric equation. So in order to have the parametric equation, we're going to compare the left hand side and right hand side. So let us compare for the I. So over here we have x equal to, so this one we have 2. And then this one I have t times with negative 1, so this is minus t. Compare for the j, we have y equal to, so over here I got negative 3. And then t times with 5, so this is plus 5t. And then I have z equal to, so over here we got a 4, so 4 plus with 3t. So this is called the parametric equation. And now let us obtain the last one, the Cartesian equation. So for Cartesian equation, I need to make sure I have t as the subject. So I should bring the 2 to the left hand side and divide them by the coefficient of t. So this one is x minus 2 over negative 1 equal to, so bring negative 3 to the left hand side, we're going to get y plus 3 over 5 equal to z minus 4 over 3. So this is our Cartesian equation. Okay, so now let us go to the second example. So find the equation of a straight line that passed through the point A and B. So again, write down the equation of a straight line, r equal to a plus dv. Again, for this example, I'm going to do all three of them. So again, we're going to see how we do it for the vector, parametric and symmetric equation or Cartesian equation. Okay, so firstly, imagine this is our line. So we're going to have 2 points. So we have a point A and a point B. So based on the equation, this is a fixed point. So that means I can use either A or B for them. So either one will do. So t is simply a parameter, so it doesn't really matter. But v is actually a vector such that it should be parallel to our line. So now this is our line. I couldn't see anything that is parallel to the line yet. So that means I should find what is the vector. So I have 2 points, so I can actually get a direction vector going from A to B. So this is a vector such that it should be parallel to our line. So I'm going to use AB as the V. Okay, so let us calculate AB first. So AB is actually OB minus with OA. So 2, 1, 4 minus with 1, negative 2 and 3. So 2 minus 1, 1, 3 and 1. So let us obtain the vector equation. So for the vector equation, the fixed point, I can use A as the fixed point or B. So let me choose A. So this is xi plus yj plus zk. So this is r equal to A is I minus 2j plus 3k plus with t times with I plus with 3j plus with k. So that is the vector equation. So now let us obtain the parametric equation. So parametric equation, we're going to compare the left hand side and right hand side for this one. So if you compare for the I, on the left hand side we have x, on the right hand side we have 1, and then t times with I, so this is 1 plus t. For the y, I'm going to have negative 2, and then t times with 3, so negative 2 plus 3t, and then z is equal to 3, and then plus with t. So that is the parametric equation. So now the last one, we have Cartesian equation or the symmetry equation. So we're going to let t as the subject. So bring the 1 to the left hand side. We're going to have x minus 1 equal to, so this one bring negative 2 to the left hand side, divide them by 3. So we are going to have y plus 2 over 3 equal to, and then z minus 3. So that's all. We have already obtained all 3 equations. So I'm going to see you guys tomorrow. So we're going to do some more example how to find the equation of a line. So see you.